Yesterday, I got the chance to talk with Matt Ouille about their migration of a critical internal service, their service catalog, and how they moved it from a struggling Python monolith to an event-driven architecture. We dove into how Matt's team tackled performance nightmares like the page 11 bug, and why empathetic, hands-on collaboration was the key to turning all of their internal customers from reluctant stakeholders into migration champions. If you've ever felt trapped by tech debt or wonder how real-world teams overcome messy scaling problems, this episode's for you. Enjoy. All right. Well, here we go. The first turn migration interview. And today, to get started, we've got Matt Ouille on the show. Matt, welcome.
Thanks for having me.
Thanks for coming. We're super excited to hear you talk about some of the migrations you've done. Let's start with a little bit about you. Give me your background. Where have you worked?
Yeah. So I started my career off in Dallas. I worked for some startups, some kind of traditional, like really large businesses. Worked for the railroad for a little while. Dabbled in a little bit of e-commerce. Later went on to go work. I moved off to the West Coast, went to go work for Intuit in several different departments that they had there. And now I work at Slack.
Awesome. So what's the migration you want to talk to today?
Probably one of the bigger, more complicated migrations that I've done was a live system that did, you could think of it like information association. So something like a service catalog, but probably that and then some kind of deal. So just, yeah, context from the outset seemed pretty simple. It's a regular old Python code base, moving from one version to another. You've got, a UI, you've got a backend, all the typical big components of a software ecosystem. But yeah, it definitely grew to be a lot more complicated than I think we'd projected from the outset.
Interesting. So what prompted you to do this migration? You had a tech stack, but you felt like you needed to change it?
Yeah, there were a number of factors. Really, our data model needed a lot of upgrades. And there were customers who were dependent on that data model, which is kind of this interesting intersection of like, a business requirement to keep serving something, but also a technical requirement to get off of it because it's becoming like less scalable or too complex or too archaic. The other part was that technology had sort of dwindled. It was pretty old. And some of the architectural decisions by that time that had been made strategically kind of put the software in a corner, where it wasn't really easy to pivot out of. I know this is something that like you listen to software leadership podcasts and, read books on this stuff. Like there are people who talk about architecture is strategy, and you're constantly trying to think 1-2 steps ahead of like, if I make this decision, do I have a way to get out of it or a way to back out or a new direction that I can go in from there? And I think this software just over time, with the confluence of priorities and parameters that were on it, it landed itself in a corner where it really couldn't shift that much anymore. And so then there was really this kind of burgeoning choice of like, migrate or die. And so we migrated.
Interesting. So tell me a little bit more about the technical choices there. Was there anything in particular that really stuck out to you as like, oh, that's what's killing us, like this particular choice?
There's a couple factors here. The bigger one that I would say is probably there were choices made for expediency that I think in the short term helped deliver something, but like as that decision like piled up over years, it became sort of unscalable. So think about, with a service catalog, you deal with a lot of data throughput. Older service catalogs you'll see are very batch oriented. They get like very bursty workloads. And bursty workloads are, like they're hard to adapt to because then you have to schedule a lot of resources for, whatever the peak of that workload is going to potentially be. Otherwise, you start to have most likely catastrophic failure across the system. And so I think that's probably one of the bigger things that we started to see is that where we were storing like simple decisions, like, taking a column in an RDBMS and storing JSON values into it that you just keep appending to over time. It turns out RDBMSs don't really like that too much. Like when that individual cell across a whole column gets really massive per row, it starts to do like really interesting things to the performance characteristics of the RDBMS. Like there's no way to optimize that. You just have to shift. I think one of the other big motivating factors was getting away from the back end, even in the front end, there's some difficulty there because our libraries were so outdated that you couldn't linearly upgrade anymore, which was a really interesting problem to have. Like React is stuck like major versions behind. There's a point in like you have a dependency on a certain component library and you can't like upgrade through that. It becomes really tricky because then at some point you actually have to like break and rewrite your front end in order to like get a new front end, which then, opportunity cost starts to look at like, well, why wouldn't we just do that all in one big swoop, right? There's always a temptation of like, yeah, if we're going to have to go rewrite our front end and we've decided that our back end is not optimal, why don't we just do both?
That makes a ton of sense.
Yeah.
So, just because some folks might not be clear with it, what is a service catalog?
Yeah, that's a great question. A service catalog, you can think of it like the Dewey Decimal System of an enterprise. It's only really big companies tend to have these kind of things. And it's where you have so many services that people can't, name them with their memory or their fingers or, whatever. Like there's too many services powering either the enterprise or the core products or, whatever, that people can't find information out about them anymore. So you need a catalog to go find them. In really large, I would say like competent enterprises, what you see is, or like software competent enterprises, is that you see a service catalog play a larger role in connecting different systems across the enterprise. So it sort of becomes like your like nerve center of your enterprise. It knows a little bit about everything. It doesn't know everything about everything, but it knows enough to point systems at other systems. So think about like if I wanted to understand how to contact a given team, and the enterprise supports, Slack or email or PagerDuty as like main forms of contact information, something's got to tell me how to get to the point, whether it's a web endpoint or whether it's an ID or an email address. Something's got to tell me how to get there. Because as you grow as an enterprise, you have these common needs to programmatically be able to do that, to have systems that do that on behalf of other systems. And so that's what a service catalog does across an array of subjects, not just, contacting people.
Perfect. That's an awesome overview. You mentioned scale earlier and how this system had hit a tipping point with scale. Where did you see the points of integration? Because as you described, service catalogs act as the primary hub for describing information. But what are some of those sources of load that will actually create scale internally on this service?
Yeah, that's a really great question too. In our old world, there were a lot of bursty workloads that I would say were a threat to the service, because the way that we would provision that service is it almost, I used to joke that it kind of looked like a game server at times. Like it was provisioned really heavily, which, if you take one glance at it, you're like, oh my gosh, like why do we have a game server provisioned in the cloud for this kind of thing? And it's like, well, when this thing gets slammed with requests, because like you don't get to decide when your users make requests, right? Like they make them when they need them, and you need to be prepared to absorb them as a service owner. And that was probably, we would see just an influx of poorly timed requests that everybody made a request all at once, and you just, the backend got slammed. And maybe we weren't able to serve the pages, but there were also simple missteps. Like, when that service first stood up, it was really small. It served a very specific purpose. And so it didn't have like pagination built in, because like, if you're building a backend and you have this small, finely scoped use case, building something like pagination may just seem like overhead that you don't want to do. But it can bite you as time goes on, because now you're fetching like your entire table all at once, instead of, breaking that into manageable chunks. So, I mean, it's just like, it really wasn't like any one factor. It's like a kind of a buildup of factors there that, I think made the choice to us more obvious that when we moved to a new system, we needed to move to something that was a lot more event driven. So we were going to receive updates over time. As other systems updated, they would send us updates instead of, one really big update all at once. And so the biggest part of that was an architecture change. But along with that also came changing our schema. We were highly monolithic in the beginning, and we're still monolithic. But I would say that we made it more possible to pull functionality out of the monolith and be able to scale it horizontally if we needed to. So like certain subsets of that monolith could actually become microservices. So we stayed with this more simple monolithic architecture, but for certain things that really needed to scale really well, we busted those out into microservices that back up the monolith. And that I've heard that the strategy kind of, it puts cost and performance at odds, but in our case, it actually didn't. It blended them really well, because we kept the simple developer experience of working on a monolith, the reason people like to work on monoliths. But we also gave those microservices a real purpose behind that monolith, which is to say, yes, it's fulfilling a service, it's fulfilling a function within this service that's direly needed. It's to be able to scale a lot easier. I think that's probably one of the smarter things we did, was thinking about like what in this like really gets slammed and needs to scale, and what of it can just all stay together and be more simple.
Awesome. So you'd mentioned earlier there were a couple of original tech choices that felt like, at least at the time you decided, that felt like dead ends. As you're making these architectural choices, where did you start technically? What libraries and frameworks were you using, and what did you decide to change to? I'm really curious what you felt needed to change because it was old, and what needed to change because it supported this new architectural direction.
Yeah, that all started with kind of just a document of my frustrations. It was just like what operationally makes me, because it's some context, like I'm a person that I actually love to work on software. It is my absolute joy that I get to have a career where I get to do something that I love every day. So with that out of the way, I do generally just like to work on software. I like tinkering with stuff. I like operating software. So when I start to not like working on a piece of software, that's usually kind of a tell. Is it's like, well, maybe something's wrong. Maybe the incentives are wrong. Maybe the operational toil is off. Like something's there. I may not know what it is at the time. For the most part, what we were finding is that we had so many operational issues that they actually outweighed my ability to do forward-leaning development.
Interesting.
So I
what
couldn't.
sort of operational issues?
Yeah, talking about like the service just running out of memory and dying during a wave of requests, and those waves of requests would come throughout the day. And like our customers, they would be very vocal. They'd come to us and be like, "Hey, my systems are failing because your system is failing. Like, what's going on?" And then I'd have to explain this complex cosm of history, that landed us where we are. And it's like, well, I can either continue to do that, or I can try to focus on a future where we don't have to do that kind of thing.
Cool. So what changes did you end up making?
So I think the big thing was we moved, in our case, from Flask, which I'm sure most people in the PyCon world remember Flask. Probably still lots of users today. We moved to an asynchronous framework in Python. It's called Fast API. There weren't too many opinions about which framework to use, to be honest. It was just like, if we want to stay in Python, that's fine. We can at least reuse a lot of our like models and code and stuff like that, which is great. Reuse is what you actually get to reuse is probably not a ton, but you can at least model the logic a lot easier because it's all in the same language. But there weren't too many opinions on what framework to use. So it was just like, okay, let's pick one that's async because that's our big struggle is like, we need to get more use out of an individual unit of work than we're getting today. So that's to say, like, the asynchronous model in Python isn't what you would think it would be, but it's a lot better than synchronously handling every request. You can think of a lot of synchronous Python frameworks, like they do a thing and then they stop receiving any new things that they can do. And then once they're done, then they're open for another thing. And it's like, door shut, doors open, door shut, door open. You can think of it like that. Whereas in asynchronous, the door is always open and people come in and like form a line and, the asynchronous framework says, oh, you need this done. Okay, let me work on that. And then it can talk to another person while it's like waiting on something to come back for that. I think there's like a whole cheeseburger restaurant example that's like kind of a good imagery of, what this kind of concurrency looks like in Python. But I'm
just imagining the Krispy Kreme donut line. That's what I always go to.
Exactly. So yeah, that's we knew we wanted to move to an asynchronous framework. On the UI side, or sorry, actually, I'm going to stick on the back end. We also knew that we wanted to start working in more of an eventing capacity rather than this like batch update. We wanted to like really encourage our customers to work in the context of an event. Like, you receive an update, you send me an update. Because really a service catalog, the value of it is built by being accurate and up to date. And so if it's not accurate and up to date, then it's kind of useless. So yeah, having better patterns for getting information in from, what we call like authoritative systems was huge. And then on the UI side, that was actually our more interesting one. I had a lot of fun doing that because the migration really had to do with getting React upgraded, but then also picking a component framework that people who are like back-end engineers can work on and understand. And that you didn't have to be this, like career front-end engineer to come build on our UI, because that's the other part of the service catalog is there's machines that talk to it, but there's also humans. And so sometimes those people who are putting data into your system, they want to come build UIs to, express their data to a user. And so we knew we needed to optimize that for engineers who were not particularly oriented towards front end development.
That makes a ton of sense. That's a really interesting constraint.
Yeah. This is kind of why I like internal tools, is because you have, it's a fun space to be in, like you get to work all across the stack, but with interesting constraints usually.
So you've got this huge number of changes. You've got framework upgrades. You've got logic rewrites. You're going to break some of this out into microservices, and you're going to go into a different front end paradigm. What did you do first? How do you start to break apart this huge change?
A lot of it, the way we started was actually building an isolation. So we took a copy of the database, we built a brand new database, and we made a rule that we're not going to change the database. Both applications, the new one and the old one, are going to use that old database schema, and they won't change it. Which at the time, like, in hindsight, that was tough. And I don't know that I would do that way again, but also I don't know that there's another way we could have done it. Because in reality, there are customers who depended on that data, and we could either do all the development and then migrate them. Essentially what we were doing is we were building like that JSON column, for instance. We built out an entire system to house the data that formerly housed. It had a whole new set of APIs. It had its own database, actually multiple databases. And yeah, it was rather, there was a lot of work put into like making all that scalable on its own. But then we had to switch customers from that old column and that old data set to that new column. And then we had to, on top of that, because they're switching to a new system, they had to switch to our main new system as well. So there was all these customer migrations that happened. A lot of the way that I designed tackling that is I was like, well, this new system, it has to be built from a spec. So Open API is what we chose. Mm-hmm. And we were able to generate SDKs for our customers to use. So I was like, I can't stop the flow of pain to my customers through a migration, like just not possible. But what I can do is I can offer them I can offer them an easier off-ramp to that pain, which is go do this for me now. And the benefits you'll get are the things that resolve like the things you've complained about in the past, like availability and performance and stuff like that, like data accuracy. And honestly, most of our customers, I didn't really find one of our customers that was, once they heard that we were going to have a new system that was faster and more available, they were happy to use it.
So they were willing to essentially eat the pain of moving over and changing their workflows because they knew they were feeling the same pain that you were of this system isn't available during, the most critical periods.
Exactly. Yeah. There's definitely a lot of, that's probably one of the bigger things that I learned as like an engineering leader is if you're feeling the pain of like dragging a service forward, your customers probably are too. And it's worth like engaging in and like decomposing that pain. I'm finding out where your customers are because they may be more amicable to the solutions that you have in your head than you think.
Mm-hmm. Absolutely. That makes a ton of sense. Okay. What was the weirdest like edge case you hit while you were dragging a customer from the old version to the new version or holding hands and moving them into the future?
Yeah. Weirdest edge case. Honestly, it was like small data incompatibility issues. We had, this isn't totally sequitur to what you're asking, but
go for it.
That JSON column that I keep referencing, it had this really odd bug where I would paginate through our entire API, but I would get to page 11. And page 11 would just take like minutes to load. And like, I did all this work to like optimize the schema. I did all this, asynchronous, like DB connections, like everything that I could think of that I was like, okay, I'm going from simple to hard. And then I exhausted every solution that I could think of. And I was just like, what in the world? Like, wow, why page 11 every time?
What happened?
So I was sitting on a call with one of the other engineers one day, and he was helping me fork the database because we were finally at a point in our like journey where we were separating the database. So the old application was officially living an entire environment that was all its own. There was only one user on it. Like, so we're finally getting free of this data structure. I hit that page 11 and I just like, I just erupted in this like rant, and I'm like, I don't get it. Page 11, like every single time, like it kills me. And even in my local environment, like even in my local environments, I could reproduce this, but I could never figure out why. I would turn on database slow logs, like everything. That engineer had the wisdom to go take every call that was happening, or basically the query that was making, and he took every item that was on page 11 and ran the query individually. And he found 3 where that column was so massive that it could actually topple our application, because it would try to like store everything in memory and like, cache it. And then like, and then it had to, some of this, like it's doing like unmarshalling and marshalling of data, like data normalization. And so like by the time it gets in normal applications, you know, like this is just normal stuff you do. It's very transactional, like boom, 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 boom. You barely notice, you know, memory going up and down or CPU going up and down. But because this was so massive, every single step we took was like walking with jugs of water strapped to your feet. And he found those 3 queries, and there were 3 items. We literally just nulled the column out. And then all of a sudden, like, boom, everything across the whole system just like stabilized. All the weird issues that I would see in other APIs and other systems, stopped. And it was like an evergreen atmosphere. It was like walking out of a desert and into a forest. Like, what? It's just different.
That's amazing. That's amazing. I love that. You never know what you're gonna hit. So you fork the data, moved a bunch of stuff over. You've got customers coming over. How did you? Let's zoom to the end of the migration. What kind of cleanup did you have to do? Like, what was the last few pieces that really made everything fall into place where you could declare it done?
The biggest thing I think was the data cleanup that we had saved. I'd put a bunch of, like other teams, we use programmatic models to control our schema. I put a bunch of comments on all kinds of like table fields, on APIs that I didn't want to exist anymore. When we switched to the new application, I could kind of get rid of the APIs pretty quickly. But the data model had to stay the same for a long time. And once we were able to start cleaning that up, I think is when I really felt like, okay, this has gone from something that was very brownfield to it's all the same business logic. It's the same application, but it feels greenfield. And I mean, it's a rewrite. It is sort of greenfield, but it's when you're building on an old data structure and an old API that people depend on, it sort of feels greenfield and brownfield. You know, it's like, but that moment when we were free to pivot our data structure, that was like, you know, the chains falling off kind of moment.
Awesome. That must have been a great feeling.
Yeah.
Let's talk tooling a little bit. What tools did you use throughout this process? What was the most useful?
Probably biggest one is the Open API Generator CLI. I use that on virtually every one of the projects that I've worked at in my last 3 companies. I used to use Protobuf and gRPC for the same sort of deal. I ended up switching to OpenAPI at some point, and I honestly just never turned back. Like, it's
I haven't
trouble
used it.
to.
What is OpenAPI?
OpenAPI is a spec. You can think of it. I mean, REST is pretty well known in like its structures and constraints. OpenAPI puts a spec to that. So they say you have a certain number of like endpoints, and these are the like HTTP verbs that you can use with this. There's like get, post, patch, delete, and like you'd probably have two kinds of get requests. There's like list and like get this thing. But it makes putting all of that into a canonical document that can then be used to generate SDKs really easy. It makes it very deterministic. You know, it's kind of like the difference between how would you say it? Like well, I guess that's a bad. I was going to give a poor example.
So, cool. I haven't used that. Sounds awesome. How did you use it in this particular switch? Like, you made it. I could sort of see how you started with a change, but how did you end up using it for this particular migration?
The big thing that we did was decide that, like what the minimum number of endpoints that we were going to have per API was. So like what kind of things would you want to do on them? Like list, you want to get an object, you want to update an object, and you want to delete one. And then that kind of expanded. And once we had that expansion of like hard delete, soft delete, list, update, and then get an object, then it was like, okay, now we can build our spec across like pretty broadly. We can always add stuff in the future. It's, you know, coming up with that minimum list that's really important. And then we started generating. So we started with a server. So you define the server, and then from there it creates a spec. And then from the spec, you create the client. There's another way to do that that's slightly different. Some people have opinions on it, but it all works the same for the most part. And then from there, we were creating clients. And a lot of that we were using in the early days of our clients is people who were a little bit faster moving users of ours that could update their own dependencies pretty quickly. We were onboarding them to that new service pretty early. So we would generate them a client and we'd be like, hey, you know, this is going to be kind of hairy for the beginning, but, you know, if you want something more stable and more scalable, try out this API instead. And so we just kind of slowly started moving people, so that our noisiest of our customers, were able to get some peace. And then that gave us peace to be able to work, so that we weren't having to respond to like operational issues with the service all the time.
Makes sense. As you move people over, how did you think about correctness? Were you testing ahead of things? Were these the kind of things that you could only test with real production data? Like, how did you know that the new client was correct, and how did you make it more correct over time?
Yeah, a lot of tests. I think with that code base, there's something like, it's like 400 to 600 tests in total. Yeah, it's because it's coming from a place, you know, that was, it already existed for like 8 years before this. So we could kind of redefine the APIs, but like at the end of the day, they're still having to deal with the underlying data structure the way that it is today. And it couldn't change that. Otherwise the old application breaks. So it's an interesting constraint to have. We built a lot of, I mean, you could describe it as middleware that would like normalize values back and forth. Actually, now that I'm talking about this, our IDs were UUIDs, but they were implemented in a time where you generally used strings for those UUIDs, which is like kind of hard to imagine because that I don't even remember that being a thing, so it has to be like super far into the past. But the day that I switched all of those UUIDs to proper UUIDs was also like kind of a watershed moment. But yeah, there's a lot of tests. And then anytime that we built features on the new API, we built them on top of the old database. So you had to start from a place of the original data. And we had to prove that there were going to be no data migrations that could adversely affect the old application.
Mm-hmm. Makes sense. Did you, as you were generating these tests and kind of generating this middleware, did you do that all manually, or was there any amount of automation or scaffolding that you did to make that faster?
Gosh, I wish. Yeah, there was scaffolding. The scaffolding existed in my head of like, I know these APIs are somewhat the same, so I'm going to copy and paste for the most part, and then we'll see which ones don't add up. Sometimes that led to bugs, but most of the time it let us work a little faster, and that like, a list endpoint, no matter the thing that you're trying to do on that endpoint, like they all kind of work the same. Some of the points are a little different and they have contracts on them. Maintaining those contracts is important. So those required extra tests. But yeah, I would say it was a lot of attention to detail, putting it in front of our customers. I would say one of the probably important things is we weren't afraid to be wrong in front of our customers and to like quickly fix things for them. I think there's kind of like two philosophical views of this, where there's like maximum assurance, and like you don't release until you're like absolutely sure that something's not going to break something for somebody. But as distributed systems get more complex, it's really hard to do that. And you kind of like, you actually end up harming your customers in some way by doing that. So I took the attitude, I was like, we're not going to move fast and break things. I don't think that's right either, but we're not going to be afraid to be wrong and in front of our customers, and we're going to be willing to fix it if we are wrong. And I think that was a major like superpower for us in like a socio-technical sense, because it's like, it showed our customers we cared, and that we were willing to do things to make things right.
That makes sense. That's actually a great segue into the last topic I wanted to talk about, which is kind of the human side of migrations. How did you navigate that conversation with your customers of we're going to have a big change and it's going to be, it might be imperfect when we start? How did you think about engaging with those customers and kind of telling the story of this is the work we're going to do and this is your part in it?
Probably the biggest thing that I led with is that I issued hard deadlines. That's almost the first thing that I hear anytime in an enterprise, or, when a little customer is talking to a big company, they're always going to ask about deadlines. When is this going to impact me? And there's a odd thing that happens when you start talking about deadlines, is it actually draws the work closer to that deadline.
Oh, interesting.
People will start to align on your deadline, which is how deadlines in a lot of ways get pushed back, because then unforeseen things happen, or the work is bigger than they expected, and whatever. Yeah, it's so I eschewed talking about deadlines with customers. And I said, it's on our radar. We want you to switch. And then the other thing that I also offered that I thought was really powerful is partnership. I'll come help you. If you don't have time, if it's not in your priorities, show me your code, what it's trying to accomplish, and I know how to do that on our APIs. I'll help you. I didn't do that for every case. I can't scale myself infinitely, but if they were truly stuck and they could show me, like, hey, I just don't have the people power to go do this, I'll come help. Because I get it. It's migrating software is hard. So I had a lot of empathy for our customers that they too are going through a migration. Their migration is me. And wouldn't it be nice if I could tell Python, like, you are frustrating me. Can you just help me? Unfortunately, buck stops with me in that case and not Python. But
Did you find that there were certain customers who were more excited to have you come and help versus certain customers who were maybe less excited about that?
Yeah, I mean, explaining things to people is its own overhead. It's its own tax, right? And if people don't understand their own software enough or feel like their software is so complex that it's going to be hard to get you to do this independently, so they might as well just do it anyway. Yeah, that's obviously like a cost benefit that they do completely transparently to you. But yeah, we definitely had customers that I think were more open to the idea of somebody else coming and touching their code. And because some teams are pretty particular about that, and like I get it too. Yeah, like who's this guy with this funny last name who wants to come and touch my code base? Like, um,
were there other folks on your team who were engaging with customers the same way, or were you the face of this migration?
Yeah, I would say it. I mean, our team is very willing to help. Like, if they can see and understand pain, they're willing to jump out there and really do anything, which is kind of a magical thing about the team that did this work. It was super cool to watch because I got to see them in private meetings talk about, like, they really empathize with our customers. Not only is it important work to them, I think that's kind of the interesting thing in tech is, like, you always see people who are fascinated by the problem and the system and stuff like that. But to see people and observe people who truly care about their customers in this, like, deep way, and like what happens to them and what they deal with, and their language around that is so technical and yet human oriented, is just fascinating. So yeah, very lucky in that way.
That's great. That's a specialty, especially with internal customers where it's easy to offload and easy to think about, like, wow, this is not something that, like, the business is measuring revenue against. They're stuck here.
Yeah, 100%.
That's great to still feel that user empathy, still have that sense of customer focus. If you had to do it again, what would you do differently in interacting with those customers?
I think knowing what I know now, I would probably have some forward-facing documentation, rather than relying on people either figuring things out or us hand-holding them or whatever. Now, also, to be fair to our strategy, we did try to have a lot of forward-leaning documentation. It was just, we learned a lot through the process. And I think that was really drove a lot of, like, our outlook slightly shifted all the time, as we learned things through the migration or as our customers experience pain. Like, we would stop doing something, or we would change the way that we did it. So it's, I think that's, if I were to do anything differently, I think I would try to, like, put our customers in a closer, like, room together and then have that documentation so that it, like, evolves as they're watching. They're more a part of that evolution rather than, just trying to navigate this migration.
Yeah, absolutely. Having docs and having a clear, like, evolving understanding seems really critical to getting anything done.
Yeah.
Cool. So what's the state of the world right now?
Well, things look good. We're able to build, I would say, like, new features relatively quickly. We're able to scale a lot better. Operational, our operational outlook is definitely a lot lighter. So we get more time to think about innovation. And we get more time to partner, to do external partnerships. Because that's huge in a service catalog space, is being able to go partner with other teams, and like kind of help them build the kindling that is the fire of that like sense of innovation of how to use your system better. When your job is to provide them like capabilities, so it's really cool. As I said, like I use the term watershed, like that was very on the nose for that time period. Cause, it really changed, I think, the game for us in that, we needed to use our tooling smartly and we needed tooling that worked for us. Without that, we were always going to be playing catch up.
Cool. What's the next big thing?
That I think remains to be seen. I've done a lot of stuff in my career. I worked kind of all over the place, from systems engineering to software engineering. Worked at startups, big companies. So I don't know. Remains to be seen. I think my mind's open.
Very cool. All right. Couple quick questions as we wrap up. So, jump into a lightning round sort of set of questions. If you had to pick one word to describe this migration, what would it be?
Very tactical, or like kinetic.
Cool. If you could wave a magic wand and create a tool that would have made this migration go faster, what would it be?
I think if I had sort of like I use the LLMs, not at work, but I use them at home. They're pretty good at writing tests. But if I could show an LLM the context, like the schema of my existing project, and I could tell it what I want to get to, and it could knock a lot of that boilerplate out for me, whether it's the structure and just the tests, like that lets me focus on the last mile on the business logic. And like, if it can help me figure out compatibility issues, like designing tests for compatibility issues, that would have saved me probably 4 months, if I had to guess.
Beginning, middle, or end, where do you think morale was highest in this migration?
Definitely the end. That watershed moment where we nulled out that column and everything just stabilized. I mean, there was a piece of me that was really worried that we'd built a system that didn't scale. And I was just like, oh boy, I have wasted millions of dollars. I am that guy now.
I like to ask that because it's not always the end. Sometimes it didn't work.
Yeah. Well, and honestly, had that engineer not been curious enough and had that energy, and maybe even, the psychological safety to just go piece through each of those entries on that page, and had he not been listening to me with an empathetic ear, we would have never found it. I wouldn't have found it. And maybe that's a mark against me. Maybe I should know more about databases, but that's, still, software, I think, is where the term always remains true. Like, it does kind of take a village, because like you could be the perfect T-shaped engineer and you can't know everything.
Months of work and, hours upon hours of collaboration to get lucky one afternoon.
Yep. 100%.
And last question, where can folks find you on the internet if they want to learn more?
Yeah, so I've got a website, ooo-yay.com. It's phonetic of my name.
Yay.
And I'm also on LinkedIn. I think that's really I'm also on Hacker News under the same name. I think there's no dash. Yeah, come say hi.
All right. Well, thanks so much, Matt. Glad to have you here.
Thanks to you, TR.